All right, this is the last section for our last unit for the 9 weeks, and this is going to be transformations. So what is a transformation? It's when a geometric figure changes in position, shape, or size. So here are your 4 basic transformations. You have when a figure flips over, so it's kind of like a mirror image, slides, or turns. And this is the one we've kind of done already where it changes in size. So we did a couple of dilations already. In isometry is going to be a transformation in which the pre-image and image are going to be congruent. So we're going to basically do all isometries today. Some notations you'll need to know that is going to be used on these transformation rules is the first bullet is when a transformation maps a figure onto its image, and it's described by an arrow notation. So we're going to use that arrow. Prime notation, I've said the word prime before, and it has an apostrophe on those images. That's used to identify the image points. And so in the figure, you have K prime, that's the image of K. And so it looks like this. K maps onto K prime. And so to do the whole figure, you have triangle JKQ, and it maps onto triangle J prime, K prime, Q prime. So let's look at the first one, translations. A translation is an isometry that slides a figure along a straight line path, moving each point the same distance in the same direction. So as you look at this figure here, it shows a translation of the black square sliding 9 units to the right and 3 units down. So here's how you write that rule. 9 to the right would be +9 to the x coordinate. 3 down would be -3 to the y coordinate. All right, that's how you write a rule. Let's try one more. So I have a picture of a translation. And so always note the notation. So this one right here is our pre-image, and then this one is our image. So all you have to do is simply count 1, 2 to the left. So if I'm going to the left, I'm going to go -2. And then I'm going to go how many down? 1, 2, 3, 4, 5, 6, 7, 9, 10, 11. 11 down, and so down is in the negative direction. And that would be the rule. So translations are going to be your easiest one. This one right here is going to be more challenging, the rotations. So rotation is an isometry in which a figure is rotated x degrees about a point, which will have its x, y, onto its image. Rotations are counterclockwise unless stated otherwise. So in this figure here, we have triangle ABC, and it's rotating 90 degrees counterclockwise. So an easy way to see that is by drawing this green segment right here from point A, and then making that 90-degree angle so that can represent the 90-degree turn. Okay, and so the way you make that 90-degree angle is you learn that slopes are opposite reciprocal. So if this goes down 4/6, that means this is going to go over 4 up 6. Okay, and so let's take a look at that coordinate. That coordinate here is 6, 4, and A prime is at -4, 6. And so you want to look at that in order to create the rule. So it went from 6, 4, and it mapped onto -4, 6. So you can see the numbers switch places. So that's what you want to do for the rule. And then you can see that the 4 became a negative. So the sign changed on the 4. So that's how you write the rule. -y, x. Let's try some more rotations. So if I need to rotate this one here about the origin 180 degrees, well, I want to draw that same line that I did earlier. It was that dotted line segment from A to the origin. And so this is going to rotate. Over here would be 90, over here would be 180. So I'm going to rotate that. Now think about it. 180-degree rotation is basically onto a flat line. So it's going to be that same flat line, and it's going to have the same slope. So if it goes down 4/6, I want to do that same thing. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So that's going to be A prime right here. And so if you look at this dotted line, it's a straight line going right through the origin. Okay, and so I'm not going to graph the whole triangle, but you can see if A was at 6, 4, A prime is now at -6, -4. So let's write the rule. It went from 6, 4, and that mapped on to -6, -4. What's happening here? The number stayed the same, except the sign changed on both of those. So your rule is going to be a simple -x, -y. Okay, and so you would do that to B and C to finish off the transformation. Okay, but we're going to go ahead and skip that. Let's go to the next rotation. This next rotation, I'm going to rotate 270 degrees. Now remember, you always go counterclockwise unless it says otherwise. So I'm going to go from here. And then remember, I'm going to go 270 degrees counterclockwise. So that's 90, 180, 270 is going to be over here. So an easy way to think about is going 90 degrees clockwise. So think of going this direction 90 degrees. So let's use the opposite reciprocal slope. If it goes down 4/6, I want to go down 6, 1, 2, 3, 4, 5, 6, over 4, 1, 2, 3, 4. So that's going to be my A prime. And if you draw the segment to there, you can clearly see that's a perfect 90-degree angle right there. And so that's the rotation of 90 this way, but 270 that direction. So that's your 270. So what is coordinate A? Coordinate A is at 6, 4, because that's the same one we've been using. Coordinate A prime is at 4, -6. So let's look at that rule. So it goes from 6, 4 to 4, -6. And so what happens here, the numbers switch places, and this time the X changed the sign, okay? So it switched places, the Y now became into the X spot, and the sign changed on the X. So that's going to be your rule for 270-degree rotation. And that's it for rotations. Let's go to the last type of transformation, and that's a reflection. This is an isometry that flips the figure across a line, okay, creating a mirror image. So here we have this figure on the left, and here's our image over here on the right. So this is the mirror image, so it's reflecting over the y-axis, okay? And so an easy way to figure out the rule is just look at one coordinate. So let's take a look at D. D is at 2, 3, 4, 5, -5, sorry, comma 2. D prime is at 5, 2. So what changed here? The sign on the X, and that's it. So that's what your rule is going to be. Your rule is going to be -x, y. And that's your rule for reflecting over the y-axis. And plus another easy way to do reflections is to just count. 1, 2, 3. If this is 3 units away, well, this is going to be 3 units away in the opposite direction. Okay. This one is 5 units away. That's going to be 5 units away. This is always going to be that midpoint from there to there. midpoint from C to C prime, midpoint from D to D prime, and so on. All right, let's try another reflection. This one, it says, graph the image of a triangle XYZ of the reflection over the line y equals 2. Actually, let's do this one first. Graph the image of PQRS of the reflection over the line y equals x. So graphing over y equals x. A lot of us forget what that looks like because we haven't been in algebra for a while, but the equation y equals x is like this, okay? So it goes through the origin, it has a slope of 1, and it looks like that. So if I'm gonna graph this over, that means this is gonna flip over here. So let me show you how to count in that opposite direction. So R is at 2 comma negative 2 comma 2. Count diagonally 1, 2 diagonals, 1, 2. There it is. That's going to be R prime. Okay, now let's keep going with the rest because it's kind of hard to figure out the rule on just one point. Q is at 1, 2, 3, 4 and a half. Half, 1, 2, 3, 4. That's where Q prime is going to be. Go with S, 1, 2, 3, 4 and a half again. Half, 1, 2, 3, 4. And you can see it's on the same line as R, so that's S prime. P prime is going to be easy to tell because I have almost my whole thing. 1, 2, 3, because I notice it is 3 units away from Q. So there's P prime, and there we go. So that is the reflection over the line y equals x. So the question is, what is the rule? Well, let's look at a point. Now here's the point you don't want to use, okay? So R was at negative 2 comma 2. R prime is at 2, negative 2. These two have the same absolute value, so it's kind of hard to tell what's happening here. Okay, you're not sure if the signs are just changing or if they're reversing positions. So let's take a look at Q. Q is the better one to use, or S, either one. Q is at negative 3, 1, 2, 3, 4, 5, 6. So Q is at negative 3, positive 6. Q prime is at 1, 2, 3, 4, 5, 6. Negative 3, 6, negative 3. So let's write that right here next to our rule. It went from negative 3 comma 6 and it mapped onto 6, negative 3. So what happened here? Looks like they just switched positions. The 3 was in the front over here on the X, now it's on the Y. This was on the Y, now it's on the X. So that's what your rule is going to look like. It's just going to be a switch of the Y and the X, and that's always going to be your rule for reflecting over that line. Okay, so be able to reflect over another type of line as well. All right, let's go back to this one. This one was graph the image of the triangle XYZ and reflect it over the line Y equals 2. So y equals 2 equation, that's this one right here. So we're going to reflect over that line. So let's go ahead and count to that line. So this is 1, 2, 3 units away, 1, 2, 3 units away. So there's my x prime. Let's look at y. Y is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, right at the top. And there's my y prime. And so z prime's on the same level as that, and so that's on the last line. So there's z prime. So let's graph all right, so there's our triangle being reflected over the line y equals 2. So what is this rule? So let's take a look at the rule here. So the coordinate of x was at 2 comma negative 1. So it went from 2, negative 1, 2. Let's see where x prime is at. 2 comma 1, 2, 3, 4, 5. 2 comma 5. Okay, let's take a look at y, because not one is just going to work. So we're going to go another one now. Let's take a look at y. Y is at 2, 3, 4. 1, 2, 3, 4, 5, 6. So that's at -6. So y is at 4 comma -6. And the new y prime is at 4 comma 10. 4 comma 10. Okay, and so it looks like the x's are staying the same. So let's go ahead and write that in our rule because the x's are not changing. Let's do this last one. The z is at 10 comma -6, and z prime is at 10 comma 10. All right, so what's happening here to the y value? Well, it looks like the sign changed, so that's one thing that we should write down. It's changing the sign because they are all negative here and then they all turn positive there. And so if they all turn the sign to positive, one thing to consider is, well, if it's going from -6 to +6, what do you do to the 6 to get 10? If this -1 is going to +1, what do you do to the 1 to get a 5? Okay, so 1 to 5, 6 to 10, 6 to 10. Well, 1 is 4 units away from 5, 6 is 4 units away from 10, and 6 is 4 units away from 10. So we're going to add 4 to the rule, okay? And so one thing to think about if this pops up again, and it will on your homework, whenever you're reflecting over a horizontal or vertical line, by the way, the vertical lines are x equals a number. Okay, so x equals 2, it goes through the x value on 2. But if ever you reflect over that, it's very similar to reflecting over the x and y axis. So you're going to want to change the sign like we did. And then you're going to want to also do somewhat of a translation. So this is kind of like a composite transformation. But this 2 right here, the 2 on the y equals 2 is just simply doubled to get that 4. Okay, so remember that, double the 2. So if you want to write a little note down, double the 2. And that gives you that number there. All right, and that's it.